Hello and Assalamualaikum. My name is Amira Haisabita Azman, and today we would like to present our project-based learning (PBL) on the quality assurance and the quality control. So for this slide, we have three presenters, which is me, Amira Haisabiti Azman. The second one will be Nur Bahija binti Mustafa, and the lastly will be Nur Hasikim binti Paritu Jalal. So for the first slide, I will explain about the type of data. So basically, there is two type of data, which is the variable data and the attribute data. For the variable data, it has a function which the data of product characteristic that can be measured. For example, length, size, weight, height, time, and velocity. And the second type of data will be the attribute data, which has a function of data of product characteristic that evaluate with a discrete choice, such as good or bad or yes or no. Okay, for the next slide will be the control chart for variables. Basically, what is variable and what is the control chart variables? Variables is a measure of characteristic in a service or product, while for the control chart variable is the measurement of data taken and erased on the chart. Basically, there is two type of chart, which are the X bar type and also the R chart type. For the X bar type, it is an average of each subgroup data which has a function to identify any alteration in mean between the subgroup. For example, is the X bar chart. For the R type chart, it is the range by each subgroup data which has a function to identify any changes variation within the subgroup. For example, the R chart, S chart, and S squared chart. Okay, so I will explain more about the type of chart. So for the first one is the X bar chart, which is it is the mean of the sample that are being plotted and has a function to control the mean value of the variables. For example, is the size of plastic bottle. For the second one is the R chart, which is the range of the sample that are being plotted and has a function to control the variability of the variables. And the S chart has a function of the standard deviation of the sample that are being plotted and has a function to control the variability of a variables. And the last one will be the S squared chart, which is the variance of the sample that are plotted in order and has a function to control the variability of variable. So the next slide will be explained by Nur Bahija binti Mustafa, and that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurbahija Mustafa, and I've presented the steps in developing control chart. The first step is to define the problem. Quality tool is used to determine the general problem that occur and also the cause. Next, a subgroup size is chosen to be sampled where homogeneous subgroup is chosen. And this homogeneous subgroup is produced under the same condition at the same time. So by minimizing the possibility of the group differences, the possibility of detecting differences between subgroups can be minimized. Next is data collection. The 20 to 25 subgroups are collected before calculating the control limit, and each time a subgroup of sample size is taken, the average for the subgroup is calculated and plotted on the control chart. Next, we will determine the trial center line, where the center line should be the population mean. And then, the trial control limit for X bar is determined. The normal curve displays the distribution of the sample average. The process will be considered under control if they have 99.73% of the graph average. Next, the trial control limit for R chart is determined. The spread of the individual sample is shown by the range chart within the subgroup. Then we will revise the chart. In some cases, control limits are revised due to the inclusion of out of control point in calculating the control limit. Or in other cases, the process is in control, but the differences within the subgroup improve. So by interpreting the original chart, isolating the causes, taking corrective action, we can revise the chart. Next, the purpose of the process is achieved, which is to reduce the variation inherent of a process over time. The dissemination of the data will continue to decrease as the method is enhanced, so we can improve the quality of the product. And the last step is to examine the process. A process is considered to be stable and under control only when the performance of the process is within the range of the calculated control limit. And thank you.
Thank you, Nurbahija, for the great presentation just now. So I will continue this presentation for the calculation part. So first I will introduce my name. So my name is Nurhasiki binti Paritu Jalan. My metric number is 1713422219. So first, before we do the calculation, we need to consider to collect the data first. So for our group, this is our data. So we choose the sample subgroup for 20 because for to collect the data, we need to make sure that the subgroup is between 20 to 25. So our group choose 20. And then for the sample, we have 5 sample, which is x1, x2, x3, x4, and x5. So this is the sample. This is the measurement for the size of the opening opening bottle for mineral bottle. So next, so follow up the second step. So for the second step, after we already obtain all the sample, for example, just now from the slide x1, x2 until x5, we need to find the average value for each subgroup. So as you can see from the table given in the slide, so each subgroup we can calculate the average value. For example, for the subgroup 1, to find it, we need to sum up all the x1 plus x2 plus x3 plus x4 and x5. After that, divide by 5. And then we obtain this value. After we already find all the sub value, then we can do the average subgroup for the x bar. So to do the x bar, this is the formula. So x bar equals to total x divided by number of subgroup. So total of x from all of these subgroup, we will sum up and then divide by 20 to find the x bar value. So we can obtain the x bar value is 47.772. So follow up with R value, R range. R also we need to find the value for the each sub. So as you can see, the total up for the R is 1.19. So for the R, we can follow up this formula, which is the X max minus with the X minimum. Next, you find, okay, after we already collect all the data, already calculate the average value, we need to find the uh, X double bar value and R bar. So how we want to find the X double bar value and also R bar? First, we need to follow up this formula, which is to find the R double bar equals to x bar divided by sub of sample, which is 47.772 and divided by 20. This is our group value because we already calculated before this. So the value obtained is 2.3886. Meanwhile, for the R, to find the R bar, we will divide R divided by 20, which is our subsample group. So 1.19, sorry, divided by 20 equals to 0.0595. So this is the R bar value. So after we calculate the X double bar and also R bar, we need to find the UCL for double bar and also LCL for the double bar. So why we want to calculate the UCL double bar and also LCL double bar? Because we want to find the boundary line for our data, whether it's upper control limit or lower control limit. So when we plot the graph, we can see is it the data we collect is over the control limit or within the control limit range. So for the UCL, so this is you can see, as you can see, the UCL, this is the X double bar value and then plus with the S square times with the R. So S square value we can find from the table. So I will show after this how we want to find the table, how we want to find the data from the table. So for the SEL, the difference between these two equation, only the UCL is the addition part and then the SEL is the subtract part. So the data obtained is 2.4229 for the UCL and then 2.3543 for the SCL. So next, next to find the UCL and LCL for the R bar. So for this part, for the UCL, the 2.1.4 is the D4 data. So D4 data also we will obtain from the table. So I will show after this time with the R value. And then for the SCL is the D3 data. So the D3 data also we can obtain from the table and time with the R bar value. So this data then we will collect and plot in the graph. So we will see the data that we collect, is it within the range or is it have a data that over the control limit line. So the UCF for the R bar we obtain is 0.1258. Meanwhile for the LCL is the 0. So next. So this is the table that I said just now, sorry. So because our sample is 5, x1, x2, x3, x4 and x5, we need to make sure that the subgroup size is at 5. So at 5, A2 value is 0.557 and then this square value is 2.326 and then D3 is 0 and D4 is 2.114. So this data will be used for the calculation before this. Okay. Okay, next. Okay, this is our X bar. As you can see, for the blue line is the X mean, and then for the orange line is the control limit. Meanwhile, for the gray line is the upper control limit, and then for the yellow line is the lower control limit. So from you can see from the our X bar chart, there are one data that over the upper control limit. Meanwhile, the other one is in the range. So from this, we can see that one data already over the upper control limit, already over the borderline. However, all the data that before this and after that in the limit range. So continue with the R bar. So this is our R bar. As you can see, the blue line, this one is the R value, R range, and then for the orange line is the control limit, and then for the gray line is the upper control limit, and for the yellow line is the lower control limit. I show you this. Yes, lower control limit. So from this we can see that for the R bar chart, the data that you collect and calculated is within the range. So it is good. So from the X bar chart, R bar chart, we can analyze. So we can do the improvement and analysis for our product. So that's all from me. Thank you very much and the end. Thank you so much.